In this video, we're going to look at trigonometry questions and all the different variations of that come up in the junior certs. So read them carefully. The three triangles A, B and C as shown below. The given lengths of the sides in centimeters, x and y, an element of natural numbers. Don't get confused, just whole numbers. In this question, take the perimeter to mean the length of the perimeter. And in part A, the perimeter of triangle A is 8. And we have two sides already, 2 and 3.5. The third side is 8 minus 2 minus 3.5. Nice easy start. So 8 minus 2 is 6, minus 3 is 3, minus a half is 2.5 centimeters. This one here, 2.5. Write down the perimeter of triangle B in terms of x. I'll do it here so I don't have to move the diagram. 3 plus 2x plus 2x plus 1 is the perimeter of B. So you have 4x plus 4 is the perimeter of B. For triangle C, before we get to C, the triangle of B is 24. So we have this is equal to 24. So 4x, if you covered it up, would have to be equal to 20, or bring the 4 across and make it a minus. So x will be 5. So just check your answer here. If x is 5, we have a 10, 2 5s, a 3, and then an 11. And you can see that does add up to 24. So the new junior cert running mixed topics. The perimeters of A, B and C form a linear sequence. An example of a linear sequence, 2, 5, 8, the same difference all the way along. So just if you think about what a linear sequence is, just jot it down to the side. We're told triangle C has the largest, and the perimeter of triangle C is k centimeters. Find the value of k. So a question that will challenge the best of them. So we have an 8, a 24 for B. So we have 8, 24. So the difference between these two numbers is 16. So if we add 16 onto 24, we get 40. And then we go back to our triangle and we say the perimeter of C is y squared plus y squared plus 3 plus 5. And all of this is equal to 40. So we have 2y squared plus 8 is equal to 40. So 2y squared would have to be equal to 32. If you bring the 8 across, dividing by 2, y squared would have to be 16. So y would have to be, can't be plus or minus 4, it just has to be plus 4. Let's check. 4 squared is 16. 16 plus 3 is 19. 16 and 19 is 35. And 5 is 40. So k centimeters was the perimeter, that's the 40 cm, and the value of y we've just got. In this question we have a diagram that looks really complicated, but it's not really when you think about trigonometry. It's just triangles. The diagram shows two vertical buildings, A and B, and the diagram is not to scale. Mary stands at the top of building A, so here's Mary standing up here. Let's give her some legs. She's 220 meters above ground, which you can see here. She wants to work out the distances marked y and z. I'm just going to go over them here. Here's y and here's z. That is the distance from the top of building A to the bottom of building B and the height of building B. So a lot of words here for a question that does not have a huge amount of work involved. Mary measures the two angles that are marked 35 and 20. She must hang off the side of this building in some way. And 20 is here. So what we're always doing, any trigonometry question, we're going to take the triangle out with the information that we have, and we are going to then work from there. So I'm going to use this triangle first. I'm going to call it triangle number 1. The first part of this question is to work out the size of angle C. So draw the triangle. Right angle is 90. We have a 35. So the two non-right angles always add up to 90, or the 3 add up to 180. So 90 minus 35 is 55 degrees. So that's what angle C has to be, or 180 minus 90 minus 35. So let's put that back on the diagram. 55 degrees. This one and this one have to add up to 90 as well. So it's also an alternate angle if you like doing that one. So that has to be 35. This one is also 90. It's a right angle. So if that one's 90 and we have a 35 already in it, well, this one is also an alternate angle to the 55 down below, or 90 minus 35. So we have all the angles. We should be able to work out all the sides. We also have a 20 in that one, so that one would have to be 70. So we've loads of information added to the diagram. We've worked out angle C. C is 55. Let's see what they want next. Y and Z. And we're asked to use the theorem of Pythagoras to find the distance marked Y. And then we're asked to use trig to work out the value of Z. So let's have a look here. Pythagoras for Y. So again, drawing the triangle. Pythagoras means we have to have two sides, which we do. We have the 154 and we have the 220. And you know that this is going to be the square root of the two straight sides squared and added together. You've done so many of these at this point of your junior cycle career. 220 squared plus 154 squared. Calculator use. So with your calculator, if it works out as a third, we'll give it to you. It's coming up as 22 by the square root of 149. You press SD to change it to a decimal to get 268.544. And then you check the question to see what form it's asked in. So let's have a look here. Correct to the nearest meter. So 269 meters for this one. And then trig to find Z. So we have Z along here. So if we take up to this point as 220, we then just have to work out from here to here. So it looks like we're looking at the top triangle this time. So let's have a look at the top triangle, take it out, do a nice sketch of it. We have a 20 degrees. If you want to just need that, we don't need the 70. We also have the 154 down the bottom, that's this side along here. So 154, I'm going to call this X. So we're looking for opposite and we have adjacent. So this is tan, SOHCAHTOA. Tan is equal to opposite over adjacent. So the tan of 20 is equal to X over 154. So cross multiplying by 154, 154 by the tan of 20 is going to be equal to X. So it's calculator use again. 154 tan 20 gives 56.05. And that will be meters. So let's just see, we're going to have to add the 220 on. So we'll do it down here. 220 plus 56. We can drop off to 0.5. Is going to be 276 meters for the height of building B. Very similar question here. Photograph on the right is of a house. Part of the roof is shown in the diagram below. AB is perpendicular to DC. So you can see here they've given you the little right angles in here. Just here. So AD is 11.8 and we have a 2 for DB. CAD is 20 and DBC is X degrees. So ACB is not right angled. ACB is not a right angle. So they're telling us ACB, this whole angle here, is not a right angle. Use trig to find the value of X. Well, we can definitely get H first and then we just have a 2. So we'll have two values there, we'll be able to find the angle. So let's draw this triangle on its own. Terrible diagram, put your 20 in. You don't need to use a ruler, it's just a sketch to help you. And we have 11.8 and we want to find H. So similar to the last question, anytime you're dealing with the straight sides, it's tan. The tan of 20 is equal to opposite over adjacent. Just write that to the side so you don't make a mistake. Draw your arrow to the opposite one, again to eliminate error, so H over 11.8. And they seem to like, whoever wrote this paper probably wrote the other one as well, because they like using the tan of 20. 11.8 tan 20 is the height of DC. If you type this into a calculator, 11.8 by the tan of 20, it's going to give 4.2948. 4.2948. I'm not going to round off too early. I'll keep it like this for now. And then if we want the angle X, again we're dealing with the two straight sides. I'm going to draw the triangle again. We have X degrees, we have 2, and we have 4.2948. 4.2948. So we can say that the tan of X, we can see it's the straight sides. Tan of X is equal to opposite, draw your arrow over adjacent, so 4.2948 over 2. And this is where you use the inverse function on your calculator, the inverse tan of this whole number here. 4.2948 over 2 will give us the size of angle x. So x is equal to, calculator use again, you can't do these questions in your head. So if you don't know how to use your calculator at this point of third year or second year, whenever you're practicing these questions, you need to start practicing quickly. 4.2948 over 2. I'm using the fraction button on a calculator. It's giving me an answer of 65.02 degrees. 65.02, and I'll imagine it's to the nearest degree here, to the nearest whole number. So x is equal to 65 degrees. Question done. In this question, we have a triangle, one length 10 and the other x. So the triangle with the side length 10, the perimeter 26. Badly phrased question here. The other side is length x, but it's actually 4. It's given here. So the third side is 26 minus 14, which is 12. And in this case, 10 and 9 is 19. 26 minus 19 is 7. So we have a 7 and a 12. Find three values of x that make it an isosceles triangle. So are they talking about diagram A or B here? Okay, so we have this triangle, we have a side length of 10, and they're giving us two values for x. So if we have a triangle and one of the sides is 10, for it to be isosceles, the two other sides need to be the same length. So we have 2x would have to be 16, so x would have to be 8. That's one value. If we have the triangle and one side is 10, what about if another side is 10? That would leave us 6. So that'll definitely work for us too. So we have three different values there, 10, 8, and 6. Here we have a graph that shows the area of the triangle for all values of x between 3 and 13. Between 3 and 13. The point A is marked. So A is the point on the graph with x equal to 4. So it represents the triangle in diagram A. Use the point A in the graph to estimate the area. Area is along here, so we just got to go to the left. Now you'd use a ruler here. It looks like it's just rub that out. Where is it? It's just below this point here, so just below 19. So just less than 19. So what will we estimate here? I'd say 18.5, and in the marking scheme, anywhere between 18.5 to 19 is what's accepted for the range of values. Let the point B on the graph represent the triangle in diagram B. So label the point B. So let's just remind ourselves in diagram B, x was 9. X was 9, so 9 would be up here. Just in here. The graph is symmetrical. Draw the axis of symmetry and write down the equation. So we know these are symmetrical between 3 and 13. Any quadratic is symmetrical. We would have to jump to 8 to get to the middle. So here's the middle. The line of symmetry goes down this way. So the y value changes all the way up, but the x value doesn't. X is equal to 8 all the way along this line. When x is 5, the triangle has side lengths of 10, 5, 10 is set, so 15 and 11. Show it's not right angled. Well, if it's right angled, the longest side squared equals the two shorter sides squared and added together. 5 squared plus 10 squared. You can see this is not right angled. 121 is not equal to 25 plus 100. So that's the last line. 121 is not equal to 125. Therefore, not, we use RA for right angled, but you'd write the words in the exam. And the diagram below shows the triangle with the biggest area, where it's 10, 8, and 8. Work out the area of this triangle. If we drop a particular here, we have two even triangles based on the eighths. So I'll take one of them here, and we can have an 8, a 5. What would make that this side here would be the square root of, it's not the only way to do it, 8 squared minus 5 squared. Square root of 64 minus 25 is the square root of 39. You may think it's wrong, it doesn't look right, does it? We normally get even numbers in these, but if you look at the question, work out the area, and the answer is in the form 5 root n. So the area of this triangle is half the base, which is half of 10. That's going to give me the 5 in here. By the perpendicular height, which is root 39. So we get 5 root 39 cm squared for the area of the triangle. So don't panic if you get something that looks a bit funny. Just continue on down to the end. So this is our third time in the last few years where we had a triangle where the two straight sides were what we were working with at an angle of 20, all in this video. You know it's tan at this point. The tan of 20 is equal to opposite over adjacent. Then I draw my arrow to opposite to make sure I get them in the right place. 6 over x. And the rule here is that the tan 20 and the x swap places. So x is equal to 6 divided by tan 20. And calculator use. Therefore, x is equal to 6 divided by tan 20. 16.484. We're looking at 2 decimal places. 16.484. Just double check the calculator. So 16.48. And is it in centimeters? Doesn't tell us what it's in, so I would write units beside it just to show that you're really smart. A different right angle triangle is shown on the right. Has sides lengths of A, B, and C. Well, A is not on the diagram here. Let's put it in. One of the angles is y. Use this to prove that cos y plus sine y is greater than 1. Cos y plus sine y. Well, let's have a look here. And we're given this information. A plus b is greater than c. So the cos of y, we'll need to find out. SOHCAHTOA. I'm sure you know all this off by heart by now, but SOHCAHTOA, just fit it in. Cos is adjacent over hypotenuse. So the cos of y adjacent is a. A over hypotenuse, which is c. So that's the cos of y. The sine of y is equal to opposite over hypotenuse. Opposite is b over hypotenuse, which is c. So we have a over c plus b over c. So it's the same denominator. That's a plus b over c. They're testing your resolve here because this is a question that you might think, we've never done this in class, but that doesn't matter. You've been taught the skills to find the cos and the sine. You can add two fractions together. If a plus b is greater than c, therefore this would be, if this is 7, c has to be less than 7. Let's say it's 6, which is greater than 1. So all you have to say is if a plus b is greater than c, therefore a plus b over c has to be greater than 1. And that ends this video.